Chapter 4, Law of Sines and Cosines and the dot product. And here's our objectives. I pulled this right out of your lecture notes, so you could go right in there and print that off if you wanted to. It's going to talk about the fact that we did some adding and subtracting in the last section, and we're going to be doing some multiplication here. It's called dot products. The definition of a dot product, basically you're going to multiply the two A values together and multiply the two B values together, and you're going to add them together. So it's not that difficult of a concept at all. So let's go ahead, let's look at some of the homework problems, and I'll be referring back to these notes periodically. The first question says, fill in the blank so that the resulting statement is true. If V is equal to A sub 1 times I plus B sub 1 times J, and W is equal to A sub 2 times I and B sub 2 times J, find the dot product. And the dot product is exactly what we're looking for, and we do that by multiplying those two parts together. Number 2, if V and W are two non-zero vectors and theta is the smallest non-negative angle between them, the product is going to be the magnitude of V times the magnitude of W times the cosine of theta. It will give you the dot product. Complete the sentence below. If your dot product turns out to be 0, then you know that cosine is equal to, cosine is 90, that your angle is 90 because the cosine of 90 is 0. So that means we're going to have an orthogonal angle, which means one that ends at the 90-degree mark. It says determine whether the statement is true below. Given two non-zero vectors, V and W, V can be decomposed into two vectors, one parallel to W and the other orthogonal to W. This is true because it's always possible to decompose the vector into two vectors, one parallel and the other orthogonal. Okay, question number 5. The definition of work indicates the work's a vector. That is false. That is false. Okay, number 6. Here we go. We're given two vectors, and we're asked to find the dot product of V and W, and then the dot product of V and V. And here's where I've worked out number 6. The dot product of V and W is 12, and the dot product of V and V would be 37. Number 7, another dot product problem, as is number 8, and I've worked those out here. If you need to, you can pause the video if you want to write those down or look more closely. Let me find the problem 9 is another dot product problem, and I have it worked out right here. Number 10, you're given U and V and W, and you're asked to do some multiple operations with them, so you need to add V and W together, and then you need to find the dot product of U and the VW sum, and that's what we have here, and it turns out to be 17. 11 asks you to do the same. They want you to multiply U by the scalar 4 and then find the dot product. So first, just do the 4 times the scalar and then do your dot product. Number 12, given these two vectors, find the angle between them. And the formula says that to find the cosine of that angle, you need your dot products divided by the product of your magnitudes. So I found the dot product to be 3, the magnitude of V to be square root of 17, and the magnitude of W to be the square root of 29. I went to my calculator and I did second cosine and entered this ratio. I multiplied 17 and 29 to get the 493. That gave me 82.2 degrees. So on your calculator, you would do second cosine 3 divided by square root of 493. And there's your answer. 13 says given that V and the W vectors, find the angle between them. So this is the same problem, just a different set of numbers. And I get a dot product of 0. If the dot product is 0, it's orthogonal. So, that's 14, but 13 is the same as 12. But 14 asks you, was it, it's orthogonal because the dot product is 0. When you find the dot product of these, it is 0. 15 and 16 will follow the same as 14. 17. 17 changes gears on us, and we are asked to find the projection, WV. So this is our formula for doing that. It is the dot product of V and W over the magnitude of W squared. Take that ratio and multiply it like a scalar by W. So first, I found the dot product. I found it to be -2. Then I found the magnitude. I found it to be the square root of 2, but I needed to square it, which gave me 2. So I have -2 over 2 multiplied by W. I reduced that to -1. When I multiplied, this is what I got. Then it asks you to find V1, which is the projection. And then V2 is when you subtract V minus V1. So I went back and got V, and then I have my V1, and I subtract those. There's 17. 18 is the same type problem. I worked it out for you because the numbers were not nearly as nice. We worked through this and we got a fraction, and I just worked through it. I don't need that parenthesis there. If you want to stop and you want to look at that, and that's a minus sign, you can stop the video and write these notes down, but I've worked out number 18. Now I know everybody gets a different problem, but I thought it might help to see one worked out. Here's 19, where they give you the vectors and they have cosine and sine in them, and we're using the same formula where or we're using the cosine formula where the cosine of theta is the dot product of the vectors times the product of their magnitudes. So you just have to take your time. The dot product is here. We're ended up multiplying the cosines together, and this should be sine. And this should be sine. I'm glad I'm going back and looking at this. Sine and sine. Now recall, cosine of alpha minus beta is cosine alpha, cosine beta, plus sine alpha, sine beta, which is exactly what we have here. So if you think of alpha as 5 pi over 2 and beta as 9 pi over 4, take your 8 and your 7 out as scalars, and that's 56 cosine of their difference. Well, when I subtract them, I get pi over 4. Well, the cosine of pi over 4 is the square root of 2 over 2. So I've got 56 times the square root of 2 over 2. I reduce that to 28 times the square root of 2. So this is my dot product. Now I find the magnitude of V when I square this. Remember back when cosine of an angle squared plus sine of an angle squared equaled 1? That's what happens to the cosine and sine. So basically you just have 8 squared, and when you take the square root you get 8. A very similar thing happens when you work with the magnitude of W. You're going to have the cosine squared and the sine squared, and they're going to go to 1, and this is going to be 7. So I have 28 square roots of 2, which is my dot product, over the product of my magnitudes, which is 56. I simplify that to the square root of 2 over 2. Now remember, cosine of theta is this. So I'm going to get second cosine, enter this on my calculator. My angle is 45 degrees. So this is a lengthy problem for you. I hope that you spend some time working on these. 20, they want to know if it's orthogonal, and the dot product turns out to be 0, so yes, it is. Spend some time working on these. When you're working through them, send me a message if you run across one that's difficult, And be sure to be on the lookout for the final video that's coming